Okay, so we do have to explain how the water cooling system on a raw water-cooled diesel engine, in this case a 1978 Yanmar 2Q it is 2025 now, so it's 47 years old or so. How does this cooling system work? Well, I will show you my best understanding. Water comes in through here. This is the pump. The pump, this guy right here, gets all its power from the crankshaft. There's some gearing inside here, inside this box. There's some gearing that allows that power from the crankshaft, is it the crankshaft? I assume it's a crankshaft. To go here. Anyway, water is now then fed into a Y. This piece of metal here directs water into the crankcase, but there's a Y here. And water can also go through what's called the bypass and skip going through the engine, go up, over, and get dumped overboard. When it's not skipped, it goes into the crankcase, bubbles up through a connection into the head, and then circulates there somehow, and then eventually comes out this hole here. I've taken a hose off for reasons, doing some stuff, taking a hose off, and then it goes into the exhaust manifold. It goes into the exhaust manifold, and then it flows out of the exhaust manifold into this pipe. Okay? And so the point of having a bypass is that when you start a diesel engine, you don't want to rob it of heat. It needs heat to run. Heat and compression being, closely related. So diesels require lots of compression and heat to make the fuel air mixture explode. Notice there are no spark plugs. Diesel engines don't need electricity to run. I use electricity to start it, but I also have a crank I can start it with. So this does not need electricity to run. And it creates its own electricity in theory to signal stuff. But that can be broken and you're just missing information. It'll still run. You can listen to it. Okay. So how does the bypass work? Great question. It works with the thermostat. When a thermostat is hot, it closes off the bypass. And it basically it forces water preferentially to go into the engine, flow through, bubble up, go through the exhaust manifold, cooling the exhaust manifold, and then go out this right here. When the engine's cold, this can flow through. This can just flow through. So again, you start the engine, it's cold. Water is flowing through freely. It can go into the engine block, but this is a much smoother path. So it just preferentially goes this way in and out. Okay, the engine's hot or hot enough. This thing shuts off, or this thing opens up, and then now it's sealed off the flow, so this guy's closed. And now the water preferentially forces itself into the engine, moves through the engine, pops out this hose, whoop, into this hole here, and then it bubbles its way through, cooling the exhaust manifold over here, and cooling this off. And so when this gets cool enough, it turns off again, and it just bypasses. Okay? So right now, a project that's coming up now is dealing with removing calcification, growth of salts on the inside of my engine, which is the problem with raw water cooling. Some engines are freshwater cooled, so what you have a heat exchanger, a way of moving seawater through one set of tubes that are contained in a jacket with water that never touches each other. Okay, so you can look that up if you want to know more about that. But this is a classic raw water cooled Yanmar 2QM20, and that has been an explanation, or the facsimile of an explanation, as to how the water comes from the sea, cools the engine with an on-off switch, and then it gets thrown out with the exhaust on the backside.